This is these are going to be the examples for section 2.2. This is for MAC 1105, College Algebra. So for this section, I'm going to go ahead and do problems 14, 20, 32, and 58. And so for number 14, I have 3 points that I'm going to see determine whether they're points on the graph of the equation. So I'm going to do it algebraically, and then I'm going to show you what it looks like when we graph the equation that were given to us. So the first thing I'm going to do algebraically, when I get a given point, I'm going to substitute the values of the variables that I'm giving to see if I get a true statement. So in this example, my y is 0. So remember, this is always xy. My y is 0. My x is 0. And so I'm just going to go ahead and replace those. So here I can see that 0 to the third power is simply 0. And then the square root of 0 is 0. And of course, I get that 0 is equal to 0, so that's a true statement. For the second one, I'm going to go ahead and substitute these values into my equation. So I get 1 is equal to 1 to the third power minus 2 square roots of 1. 1 to the third power is 1. Square root of 1 is 1. So just using, order of operations, negative 2 times 1 is negative 2. So 1 is equal to negative 1. That's clearly not a true statement, so the point 1, 1 is not on the equation. And then the last point would be 1, negative 1, so it's going to be negative 1 is equal to 1 to the third power minus 2 times the square root of 1. And then just evaluating all this, 1 to the third power is 1, square root of 1 is 1, and then I get 1 minus 2 times 1, which is negative 2, right? And then so I end up with negative 1 is equal to negative 1, and that's a true statement. So what does it look like graphically? So going here to this example, we can see here in the top on the left-hand corner here that I graphed the y is equal to x cubed minus 2 square roots of x. And then you can clearly see here that the point 0, 0 and 1, negative 1 are both on the graph of the equation. And at the point 1, 1, which is up here, is not. Let me go ahead and plot that 1, 1. So that's 1, 1 there. So that's not on the graph of the equation that we've been given. And so algebraically, we substitute. Graphically, we can simply quickly see whether or not the points are on the given equation. All right, so for number 20, here we have y is equal to x minus 6. The instructions are find the intercepts and graph each equation by plotting points. Be sure to label the intercepts. So what I have here is just an arbitrary table, an x and y table, inputs and outputs. And so I chose negative 1, 0, and 1. We are going to identify the intercepts. I'm going to show you how to do that also. And so for the first one, what I'm going to do is I'm just going to replace x with the value that I chose, which is negative 1. And so we get that when x is negative 1, our value of y is negative 7. And so the ordered pair there would be negative 1, negative 7. And so what happens when x is 0? So y is equal to 0 minus 6. So we get negative 6. So the ordered pair would be 0, negative 6. And then what happens when x is equal to 1? So we get y is equal to 1 minus 6, which is negative 5. So we get 1, negative 5 as the third point. Now, so this is clearly an intercept, right? This is the y-intercept. When x is 0, what's the value of y? For this example, it happens to be negative 6. And so do we have an x-intercept? So what we do is we make y 0 and we solve for x. So we get 0 is equal to x minus 6. So here you can see that we should add 6 to both sides so we can isolate the variable x. And x is equal to 6. So therefore, the x-intercept is 6, 0, and the y-intercept is 0, negative 6. Now, if we were to plot these points, and I'm going to go ahead and see if I can bring this over here so I can just plot them there instead of having to go between screens. And so I'm going to go ahead and try to plot some of these points. Let me get rid of these here. And so what I'm going to do here is I'm going to choose the points that were given to me. Let me move this over a little bit more so I can see my ordered pairs a little better. And so the first one that I'm going to do here is going to be -1, 7. So what happens, -1, -7. And so what happens here, oops, let me go back here. I don't want that. All right, there you go. So -1, -7. Let me move this up here so we can see it a little better. And so I go to -1 on my x, and then I go down to -7, so that's my first point. My second point is 0, 6, so again, I go to my x first, and so here's my 0, and then I go down to -6, and that's my other point. The next one is 1, -5, so again, I find my x value first, which is 1, and then I go down to -5. And then the last one would be 6, 0. And so here for this particular one, I'm going to try to shorten this a little bit. It's going to be, I go here, and it's going to be right there at 6, 0. And so if I was graphing these, I would have, let me put it up here in this one. There you go. And so how to graph by plotting points. I found 4 points. I found the x-intercept, which is 6, 0, the y-intercept, which is 0, -6. I just connected my points, and I'm done with number 20. All right, let's go to number 32. So the instructions for number 32 are plot each point, then plot the points that are symmetric to it with respect to, the first is the x-axis, the y-axis, and the origin. So the point that we're given is 5, 3. And if the point is symmetric with respect to the x-axis, then the point x, -x would also be on that graph. So if I'm given, if I'm given 5, 3, for the x-axis will simply be 5, -3. So this is the x-axis. And if it was the y-axis, then I would get, again, I start with 5, 3, and so I would have -5, 3. And then for the origin, again, the given point was 5, 3, I would have -5, -3. So that's what each of these actually means. I'm not going to go ahead and plot it on the graph, but this is what it would mean if they were asking you in a question or in the homework or a test to plot the point that is symmetric or find the point that is symmetric with respect to the x, the y-axis, and the origin. All right, let's go down to number 58. Let me read the instructions here from the textbook. So in number 58, it says list the intercepts and test for symmetry. And so for this particular one, what we're going to do first is we're going to go ahead and find the intercepts. And so remember from the previous example, perhaps some of the quickest way to find the intercepts other than graphing it would be algebraically is to make x0 solve for y, to make y0 and solve for x. So in this case here, if x is 0, I get y squared is equal to 0 plus 9, which leaves me with y squared is equal to 9. And then I take the square root of both sides, right, to get rid of that square. So I get the square root of y squared is equal to plus or minus the square root of 9, which gives me y is equal to plus or minus 3. And so just to save some space, I'm going to go ahead and write it here as plus or minus 3. The next thing is I make y0 and I solve for x. Let me get rid of this here so I have space. So 0 squared is equal to x plus 9. 0 squared is just 0. Right? And I'm going to here subtract 9 from both sides. So I get -9 is equal to x. And so my intercepts for this particular equation here are the following. I'm going to go ahead and list them all individually. So 0, 3, 0, -3, and -9, 0. And those are my my x and y intercepts. These are my y intercepts, and this is my x intercept. Okay, so how do we test for symmetry? So what we're going to do then is we have the equation y squared is equal to x plus 9. We're going to replace, for the x-axis, we're going to replace y with negative y, and we're going to see if we get the same equation, if we return to the original equation. So here I have negative y squared is equal to x plus 9. Well, if I do negative y squared, I simply end up with y squared, and so you can see that this one, in fact, will be symmetric with respect to the x-axis, because when I replace xy with x negative y, I still ended up with this original equation. Now, I know that if it's symmetric with respect to the x, it won't be with respect to the y and the origin, but I'm going to go ahead and just carry it out so you guys can actually see what it should look like when you do it. And so for the y-axis, I'm going to have y squared is equal to negative x plus 9. And you can clearly see that this does not equal the original equation, so therefore it would not be symmetric with respect to the y-axis. And then for the origin, what I'm going to do here is I'm going to replace my y with negative y and also my x with negative x. So I end up with y squared is equal to negative x plus 9. This is not equal to the original function. So this particular equation is symmetric only with respect to the x-axis. So if we go back to the problem that we had at the beginning that we did here, I'm going to go ahead and just graph it so you guys can see it. And so this is equal to, let me see if I can do that. Y squared is equal to x plus 9. And you can clearly see here that, if I were to expand it a little bit, there you go. So you can see my x-intercept here. Let me make sure, let me put a point here so you guys can see it. So that's my x. And of course, that's my y-intercept, 0, 3. And then of course, 0, negative 3. And so you can see that when we ended up doing this, we found our x-intercepts. You can clearly see them. You can see that the x-axis for that particular example acts as our mirror, if you will. And that is the last example for 2.2. Thank you.